Hey, hello everyone. I'm audible. Oh, nice. Yeah, thanks, Tamir. Thanks, Amrinder, for confirming. So, my name is Abhishek, and I am the host for today's meeting. Host, or you can say the mentor to discuss about the system design for the millions of fans. So basically, the idea of this week of Geeks for Geek is like covering all the aspects of different aspects of programming, which is like high level system design, low level system design with DSA, and you have many quizzes related to that. So you can guys attend that quiz and win prizes for the end of the week. I think so. The 21st is where they are announcing the results for the winners and the money prizes, whatever they want, they have. But for the today's topic, it will be. Uh, but today's topic it is like mostly related to high level system design, and I have two topics which I can discuss. But please let me know which one you guys are more interested into it. Okay, I don't have a formal presentation, but I will explain about the topic. So let me share my screen, and please let me know once the screen is visible. So here I will go. Yep, I think so. My screen is visible now, or not yet. Mm, it's loading. Yeah, now it's visible. Correct. Yep. So let's discuss the topic. Okay. So today, what we are going to build is like okay. So there are the two concepts. One concept is like high level system design, and another concept is like low level system design. Okay, low level system design. I'll briefly cover what is the difference between high level system design and the low level system design. Okay. So the high level system design, if someone wants to understand, is in a very simple manner. That let's say if someone says like, okay, could you please build me the application like Hotstar, or could you please build me the application like YouTube or Google Drive? What are those components which are being involved to get together to make the system end to end for a user? Okay, it does not talk about the nitty and gritty of the like how your code looks like, how your schema look like, how your tables look like. So not exactly in depth in the tables, but bit on the tables you can talk about in the high level system design. But when you talk about the low level system design, it's more on like how your flow looks like, how your code looks like, how you design your classes, how your schema looks like, how these two schemas are connected to each other. When I am saying this schema, it is mostly related to database schema. High level system design is mostly like how two components talks to each other in simple terms. Like let's say if you have a API, you send that information via the API, I receive it and I process it. I do not want to understand the logic of processing. Okay, that is what where the high level system design, and then it generates a certain output for your next microservice or next down level service. Okay, so this is the concept of high level system design, and there is a low level system design. Mostly for today's lecture we are going to discuss about the high level system design. Okay, now the scenario which we are going to discuss today is a simple scenario. Try to think of, I have two scenarios in my mind. Please let me know which scenario which you are interested in. One scenario could be like a system design for, like let's say World Cup is going on right now, correct? So in World Cup, you guys like keeps on checking into the score, like whether in the Google score you looks into the keeps on looking into the score, or second thing is like you use the crickinfo.com like to check the score. Second is like you check for the live streaming of the scores, correct? Live streaming is also there. So which part you are interested in, because both the system designs goes into the different level, which part, which part you are interested in, please let me know. I'll like try to cover the one of them. So which one, like whether we go for the Crick Info one, Crick Info system design, similar to Crick Info, not I'm saying exactly Crick Info. Second, or we can go to like live streaming of like how the live streaming will be done. So this system design you are interested in. So one or two. So like whosoever are available can vote it down, one or two, which system design you guys are interested. Live stream. Okay. So I got from Temur. It's uh, live stream. Okay. Anyone else wants to? Amrinder Sahil. Okay. Second, Prashad also said Crick Info. Okay. Two what I have. Second. Okay. Most people are interested into second one. Okay. Let's go to the second system design. Okay. The second system design, how it looks like. Okay. So there are lot many jargons which I'm going to explain. Okay, so this is also a live stream. You can, if you want to think of, like presently also we are doing the live stream, correct? So when we are doing the live stream, the same system design, you need to think of like there is something going on the playground, and then you are getting all the visuals of it. Okay, so let's think thorough and process it. Okay, so first thing is like there are the two parties involved there, correct? One is like a streamer. Okay, so for our case, streamer will be like, let's say there is a live event happening somewhere. So right now, let's say there is a uh, World Cup match of India and Pakistan, India and Afghanistan, I think so. It's going on, and soon we have a World Cup, a good match for the India and Pakistan also, which is going to happen. Okay, so everyone is excited about the matches, correct? So now India and Afghanistan match is going on. So it is going on in some playground. So think of like this is the India and Afghanistan match going on. Now this is, so in this particular case, this becomes the streamer. Okay, so this particular becomes the streamer. Okay, and for the YouTube live streaming, I becomes the streamer. Okay, now there is a one middle component in between, which is like doing a lot of jobs. So this component, what we are everyone we are interested into, and there is a third component, which is like the people who are watching. So these are like people, I can say the audience, the live audience who are looking into the game. Okay, the audience. Okay, now yeah, we'll go with the everything like Gupshup Tech. Like I think so. He written the APIs. Yeah. So we talk about the everything, but this is the component what we are interested into. Okay. Now the APIs and all we will talk about, but before that, let me tell you about something about the WebSockets first. Okay, so which is like mostly towards the audience side, and then we'll talk about that from the stream side. Okay, how the stream sides happen. So let's say whenever you watch the live streaming, there is a WebSocket get opened. Okay, now let me explain about the WebSockets first, and we'll talk about the system design from audience to. So let's say if you are not connected to the any other platform, then you will not get the data. So actually, the WebSocket is a kind of connection. Okay, let me explain a bit. Let me take some time to explain this. So whenever we talk about the, so I'm talking in the perspective of audience. Okay, so let's say you are here, this is the audience, and audience is using mobile. Okay, so this is their this is the mobile they are using. Some probably using the browser also. Okay, to get connected, or mobile. So what happens whenever a person wants to connect to the one of the host from where the live stream is happening on, it opens an WebSocket connection. Now WebSocket connection is a like exchange of information in the both the direction. It's a bi-directional change of information. Actually, once the WebSocket has been opened, it basically have a some time to live connection. Like basically it will be allowed to live for a certain interval of time, and after that it keeps on getting the data. So when I say keeps on getting the data, basically the server is pushing the data to you, and you are like, you need not to refresh anything, you need not to do anything from your end once the WebSocket connection has been successfully made. So if you want to think of like how this system design basically goes for the WebSocket connection from the perspective of audience, so basically how it happens, like there will be the load balancer. Now when I say the load balancer, it will be the load balancer of the load balancer of the company which from which you want to connect. So let's say like right now the Hotstar is streaming in India the live matches, correct? So from the Hotstar load balancer, you send the request saying that okay, I am the user ABCD. I want to connect to your server. I want to make a connection. Okay. So your request will be routed to one of the servers which are sitting here. Okay. Now these are the application servers. Okay. These are your application server. These are your, this is your load balancer. Okay. I do not want to go into the deep dive of saying that how the DNS resolution, DNS resolver resolution will happen. Okay. All these things like are quite in depth. So I'm not going into like when you say I'm hitting www.hotstar.com, correct? So this is a domain name, correct? .com. So how this will be transferred to an IP address, how you will figure it out, the IP address behind it. This is a complete another level of system design, which you guys can have a look. But I can post few of the links where you can have and check it out that this is the hotstar.com and we are like you want to connect, okay, to this IP address. Now, whenever the request is like landed on the load balancer, what the load balancer do, it basically route the request in one of the application servers. Okay, so one of the application servers, it will route it. Now let's say if you are sending the request of doing the login or you are trying to play the match, it try to set up a WebSocket connection for you for your mobile device. Now how the WebSocket connection will happen, so you have like basically WebSocket servers. Okay, so here you have the WebSocket servers. Okay, now the WebSocket server connection will directly happen to your mobiles. So let's say once the request landed on this particular application load balancer, what this application load balancer will do, let's say it verify whether you are a authenticated client or not, you have a proper permissions to watch the live stream or not, so you are a paid user or not. All these things will be application server will look into it. Once your request has been successfully verified, then it will be forwarded to your WebSocket. Now WebSocket servers, here you have the WebSocket servers. So you can consider these as the two different microservices. One microservice is this one. You have this one microservice. This has the microservice, which is like giving the connection. This is a WebSocket microservice. And this is, and sorry for the handwriting, please do not mind for the handwriting. Probably by the end of this session, what I will do, I basically share one link where you have the complete system design end to end. So you need not to worry about the like how the my end architecture looks like. So don't worry about those things out. Okay, so it will be shared within the chat in the Google chat. Okay, so yes, it's a continuous request and response. Okay, so now you have here you have like application server. Now these application servers responsibility is to authenticate. So once the authentication is everything happen, it will make a connection for you. Okay, so now these WebSocket connections are the long lived connection. Okay, so one of the example of the WebSocket connection, if I wanted to give you a very good example, think of a WhatsApp. Okay, so whenever you have a like just turn off the internet, after turning off the internet, let's say you turn off the internet of your WhatsApp, as soon as you turn on the internet, you will see that all the messages are like started flowing into it. Like you get all the messages, whatever sent by your friends and family members, you will start receiving it. Okay, so it's like basically it all sends the information. Second thing, let's say you typed some message, because of the internet connectivity you can't able to send it out, correct? So you have the like box which is not sent delivered to you. So in that particular case, what will happen, so you see that as soon as your internet connection got opened, the messages will be sent it out and you will receive the messages automatically. So this is the everything will be done by the WebSocket. So actually you are like receiving the messages and sending the messages. It's like bi-directional thing. Okay, so yeah, So this is the WebSocket. So once the WebSocket connection is assigned to you, there will be a WebSocket manager also. Okay. So what is the responsibility of the WebSocket manager? You can think it's another application or another service. Think of this as a responsibility of WebSocket manager. Now, WebSocket manager, what is the responsibility of WebSocket manager? Let's say you do the some refresh or you try to do something. Each time I should not go to the you have like WebSocket connection established, correct? I wanted to know like any other application, let's say any other application which are running, trying to send the packets. So you are receiving the packets from WebSocket servers, correct? You are receiving the packets. Now the packets will be the stream of the live videos what you are receiving. Let's say your internet is slow, someone internet is fast. They are receiving the internet that packages at the different rates. So everyone have a different packets what they are going to receive, but these packets are in should be in order. Okay, correct? So the WebSocket manager responsibility is like, let's say if this person A or the P1 is connected to WebSocket server number 1, that mapping I have with the WebSocket manager. Okay. Now let's say when I will explain the use case from the perspective of the server side, then it will become more clear that why we are using the WebSocket manager. But think of WebSocket manager, it's a mapping. It stores the mapping where let's say someone goes, and what it will do, it will go checks, okay boss, I want to check where this person is sitting and which WebSocket server it is connecting. So it will tell, okay, in the order of one time, this is the WebSocket server, this is the person connecting, and I will send the information. Okay, so that is the job of the WebSocket manager. Now let's say if somebody wants to let me give you another example which is like bit of digress from this particular topic. So let's say you are trying to send the messages, correct, whenever you start connecting. So think of a WhatsApp. Okay, you are the person who connected to the WebSocket, and there is another friend of yours, he is connected to another WebSocket, correct? Now WebSocket server, okay, within the two different machine. Now let's say your friend sends the message. Okay, now you are not going to search to all the WebSocket servers saying that, okay, which WebSocket servers I want to send this information out. Okay, where your friend can disconnect anytime, it can connect back anytime, correct? So let's say if I receive a message, to reroute that message on which particular WebSocket server, this WebSocket manager becomes handy. So what this WebSocket server will do, it has, then you have the two different level of caches also which you can utilize. One level of cache is like basically this WebSocket server probably like doing the in-memory cache, that is the one thing. Okay, then every WebSocket connection comes with some time to live, correct? So this WebSocket manager will have a time to live for this particular connection which you have made, the person. So think of this is a person P1 made a connection, this is a person P2 who made a connection. So P1 connected to WebSocket server server number 1, P2 got connected to WebSocket server number 3. Okay, in this manner. So what will happen? So P2 is trying to send you the message. Okay, so when P2 sending the message to P1, WebSocket server will go to the WebSocket manager. Now WebSocket manager has a proper mapping. He will say like, okay, WebSocket server P1 is connected to WebSocket server number 1. Could you please connect to WebSocket server number 1? It will give the information. Now, as soon as this gives the information, what WebSocket server number 3 do? It basically cache the information here itself. It does not go each and every time WebSocket manager. If each and every request is going to WebSocket manager, then WebSocket manager becomes a single point of failure. But when you are storing the information with a WebSocket server number 1, you store with the time to live. So every connection has a certain time to live. So let's say this person also is storing the information with some time to live, correct? So the same information it will store, saying that, okay, the connection with the WebSocket person P1 connected to WebSocket server number 1 is connected for 10 minutes. Okay, so that information it has. After 10 minutes within the cache, you can like just mark this entry as like flush this entry off, and after that you can again request back the WebSocket manager. If this guy is got connected, this will guy help you out again. So this way, like WebSocket manager helps you out a lot when like exchanging the information between the two services. So this is the one of the example which I wanted to tell, like how the WebSocket manager comes into the picture. Okay, so hope so it is clear to everyone. Okay, now coming to the second point. So this is like audience side, they are making a connection. Okay, so is it clear? Correct. Hope so it is clear to everyone. I explained enough. Yeah. Okay. Now coming to the second point. Now the second point will be like when you wanted to connect the audience to this particular site. So this site is quite interesting a lot. Okay. So I'll talk about lot many jargons, but please do not mind. Okay. So the first thing which you have to clear about. Okay. So streamer, basically from the streamer end, there should be some kind of medium which converts this data, which converts or which captures this data and send it out to my servers. Okay, these things are called encoders. Okay, now you have many encoders. You can have the encoders in the example of anything. So let's say we talk about the encoders. Now one encoder could be your mic and camera. Okay, second will be like your mobile phones nowadays, and third will be there is something called OBS. I am not open source, so this is open source broadcast server, something like I'm forgetting the full form of this, but this is open source broadcast server. So this is the another tool which you can use to capture the stream. So let's say right now I am streaming in the front of you, wherever the match is happening. So Hotstar people, like there are the person from the Hotstar, they are capturing the event from the cameras and all the mics and all, they are capturing the event. Okay, so this way how it basically this stream is getting captured, this particular stream is getting captured. Okay, now this is a live stream which what we are going to build up. So what we are expecting, that live stream should be remain live. Okay, so let's say you have seen that what I am trying to suggest to you here, you have seen from the real audience to the reaching to the audience who are looking into the from the stream where the live is happening, and the audience which are sitting behind it, there is a certain latency. Okay, now this latency I want to minimize as much as possible, so this becomes as minimal as possible. Okay, now okay, now think of like this what we need to think of. So now encoders done their job, like basically captures the event. Now these capturing of the events then needs to be forwarded to my servers. Now these servers are the servers which like basically start streaming. Okay, so these are my servers. Okay, these are my servers which are sitting behind. How this information changes happen? So this basically you have certain protocol. So here there is a two protocol which there exist. So real time messaging protocol, I think so, RTMP is the name, real time messaging protocol. This is a TCP based protocol. Okay, so TCP and the UDP are the two ways of exchanging the info. UDP, correct? Yeah, it's UDP. Two ways of exchanging the information, and there is another protocol, SRT. Okay, this is secure. Someone can do the Google it out. This is something secure transmission, or I'm forgetting. So UDP uses SRT. Okay, and the TCP one uses RTMP. Most of the streaming applications nowadays uses RTMP. Now the secure form of the RTMP is RTMPS. Okay, RTMPS. Okay, this is secure. S is secure. Okay, now most of the live streaming platform uses this protocol RTMP. UDP is like you know, like there is a pros and cons between the TCP and UDP. So UDP is like full secure, and UDP is not secure one. But in the case of the UDP, you will find the low latency. Correct. That is what the SRT is claiming. Okay. That but it is not yet widely used. So encoders, when they are sending the information to these particular servers, these are the servers of like let's say right now we are talking about the World Cup, then it's a Hotstar servers. if we are talking about the live stream application, then these are the YouTube servers, correct, which you are talking about. So these are the YouTube servers. They capture the information and send it out. So these camera and mic is capturing my video and sending it out, encoding it and sending it out to the Hotstar using RTMP or SRT applications. Okay. Now, once the information has been received towards the Hotstar and YouTube side, now you need to think like how we can segregate this information and then basically uh, what kind of megapixels you are trying to look, or what kind of bit rate you are expecting. Okay. How this conversion basically happened, this is what we are interested into. Okay. Now comes to this particular side. Now after receiving, so you have the encoders. So encoder, I already told what are encoders. Okay. Now before the customers there are decoders. Okay. So there are decoders. Now this place is called as, here's the segmentation will happen. Segmentation. And second thing which will happen here is patching. Okay. And these are the servers of your, if I want to say, this is Hotstar servers or YouTube server. Okay, YouTube server. Now let's say once you received a particular chunk of data. Okay. Now how many do you think like the video quality refinement is happening at when we are capturing the video from encoder, or it will be happening at the server level? Who does, like, basically what I am trying to understand, like uh, do you guys know, like, do you guys need to think of like, okay, you see the video in 1440 pixels, sometime you see the video in like 720 HD quality, sometime you see like 144 pixels. Where all these transformation happen, like if someone wants to give any idea, like whether it happens at the uh, point where the video are getting streamed, or it is done by your somewhere at the server level. So anyone wants to answer this? Come on, guys. Anyone? Where it happens? Okay, so let me answer this particular question. Okay, so whenever WebSocket level, okay, it does not happen at the WebSocket level. Okay, manager level. Okay, so do you mean by tech gupshup? Do you mean by the manager level? Does it mean like basically at the server side of the Hotstar and YouTube? Is what you are trying to say? Okay, server level. Dinesh also said server level. Okay, got it. Cool. So let's say, like, I'll explain. So basically, everything this happens at the server level. Server level is the one who, like, basically got the information. Okay, and this process is like a quite a extensive process. Okay, so and this everything is happening at the no, it's not happened at the decoder level. It happens at the server level. Let me explain that how it happens. So basically, let's say once you receive a chunk, okay, at this particular level, now your chunk will be segmented it out. Okay, now the segmentation happened for a particular chunk, because I do not want to send the information into one go to everyone. Okay, so let's say I receive a piece of chunk, I will like basically start sending that information to the users into the smaller chunks. Okay, now this chunk information, let's say you have the chunk. Okay, uh, okay, let's talk about a segment. Okay, so let's say you receive a piece of information saying that, okay, this is the video captured by the encoder, it's sent to the at your server level. Now at the server level, what will happen at this particular level? it basically divide the video into the different pixel rates or bit rates, whatever you want to say. Okay, so let's say this is becomes the 1440, this becomes 720 HD, and this becomes like 144, and I don't know like 4K whether people are supporting or not. This 4K requires a different kind of cameras to capture it, so 4K I am not pretty much sure about. 1280 is something I am aware about. So these are the different pixel units, but at the different HD or the resolution rate which you can watch the video into right now these particular days. Okay, I'm pretty much sure that I haven't seen a live streaming into the 4K type. Okay, because it required a certain different kind of infrastructure which needs to be supported. Otherwise, it is not possible. Okay, so now if you see 1440, 720, these are the pixels. Now, whenever it receives the information, parallelly these servers, like you can think of one of the microservices, what it will do, this microservices start parallelly 4 threads. Okay, for a particular chunk, 4 threads it starts. Okay, just think of a 4 threads, it restarts. Now the responsibility of these 4 threads is like this packet, the packet which has been received, okay, to convert this packet into like one of the resolution format. Okay, one of the resolution format. Now the 4 packets parallelly being processed, packet one, this, these are the same packet, p1 p1 p1, but these are getting sent into the different resolutions. These are getting converted into the different resolution. Now this particular resolution, when somebody is like converting this particular resolution, so your microservice is converting the into the particular resolution. Okay, now here comes, once these are like basically got converted into the certain format, what will happen, what basically there will be some decoder will be setting. Okay, so there will be a okay, forget about the decoder, we'll come about the decoder later on. Okay, so once like your packets are like uh, basically got converted, now in this particular case here where your audience is sitting, okay, I need to send these packets to these particular audience. Okay, now I should not send the information, I should not send the information directly to the WebSockets server, correct? Actually, so let me explain you one more way of explaining. So let's say the audience connected to WebSocket servers, correct? These are your WebSocket servers, which like basically the I say P1 person P1, person P2 connected to this, person P3 is connected to this, and person P4 is connected to this. Okay, now one thing which I like probably forget to cover, whenever there is a stream happens from a particular point, so there is there are the servers called POP. Okay, point of it's point not I'm forgetting the name, but it's POP. Okay, so point two server or something. Okay, let me just give me very quick what is a server full form. Okay, it's anyone knows about, it's like uh, point to point server. It's not point to point, it's like POP. Okay, what the responsibility of the as soon as like encoder starts, encoder wants to connect to one of your services, correct? So all over the world, wherever these matches will happen, so Hotstar, what it will do, it basically deploys the POP servers there. Okay, these POP servers. Now the responsibility of these POP server is basically whenever encoder tries to connect. Okay, so encoder basically is trying to connect, it uses DNS to connect one of the POP which is closest to it. Okay, so if POP is not closest to you, then there is a problem. Okay, so encoders trying to connect one of the POP, this way POP will route your request. So POP is like closest one, so DNS will connect to your closest server. So this is the person who connected, encoder got connected, I am like I'm getting live, so I am need to connect it into the internet first of all. and then after that there will be a POP, that is point of person point to point service or something like that. It needs to be connected to the nearest of the service, which is like again the hotstar service. Now once you are connected to POP, now POP will be connected to your segment your remaining microservices. Okay, that is your segmentation microservice or whatever you wanted to connect. So encoder sends the packet to the POP and POP sends the information to the segmentation. Now segmentation will happen in this particular fashion, like where you have like one of the microservices, you received an packet, so there will be a simple API. If you want to talk in the terms of API, there will be a simple API. So there will be a segmentation API. Okay, then you have an ID where this particular match will happen. So that is the second thing what you will got. Okay, so you can say that this is a segmentation API. You can name them as a segmentation API. Okay, what is the packet you are receiving, that information you can add it. Second thing is like you can have the ID of, like basically you can have the ID of the match which you have given. So these information you can have to the simple API, and this information received to this particular packet. Now these packets are converted into the like 1440, 720, 144 or 240 pixels. And after that what will happen, it basically start streaming these information, start streaming these particular informations to respective pipelines. When I say pipelines, that becomes more interesting. Okay, what is the meaning of the pipelines here? The pipeline meaning is simply like in which particular pipeline you are ingesting what kind of frames. Okay, so everything has a different kind of resolution, correct? Now these resolutions needs to be like basically consumed by your consumers. Okay, now when I say the consumers here is will be P1, P2, P3, correct? Now could someone tells me that each and every time do I need to send the information to all the WebSockets, or there could be some kind of optimization we can do? Anyone, any idea? Like, so let's say you receive the packet. Okay, now the packets needs to be sent to the consumers. Okay, so your consumers, or what you I wanted to say, your audience. This is the audience, what it is there. So you want to send these packets to your audience. So how these packets will be sent to the audience? It's like to all the audience I will send the packet, or I can do certain level of another level of optimization here. So anyone thinks of like what kind of optimization you can do so that audience can consume from the one particular point of contact? Anyone? Let's wait for 1 minute if I get any responses. So my question is, I will repeat my question. What kind of optimization I can do once I receive the packet? How I can send that packet to the customer in such a manner that each and every time I need not to send the packet to need not to send the packet to everyone. It's like basically one point I can send the packet and it will be done. Yeah, I'm just getting the charger. So please, meanwhile, answer the question. I'm coming back in a minute. Okay, let me answer this particular question. Okay, so let's say earlier what happens is like from a point you are sending all the information to everyone. Okay, from a point you are sending the information to everyone. But what I am trying to say, like you can do the optimization. So optimization, if someone wants to do it, how you can do the optimization in a very simple terms? It's very easy. Think of, okay, you can put a simple DNS server. Okay, a DNS server, where each and every connection will be going, each and every output from your servers basically going to this DNS servers. Now, these DNS servers are closer to the audience, correct? So as soon as like a person get authenticated, okay, what you can do, like you basically sends out the information to the DNS servers, and from the DNS server, like basically these packets, like whatever the packets you have, the P1, P2, P3 packets, okay, these you can send it out to the DNS servers directly, and then basically your customers can consume the packets from these particular DNS servers, okay, from these DNS servers. So rather than sending the packet to all the audience, you are sending the packet to one of a few of your DNS servers, where your like basically you as an application domain owner, or you as an owner of the company, like which DNS servers I want to send the information, and your audience will be collecting the information from that particular DNS server. This way you will so you will send out the minimal number of bytes to those DNS servers, rather than, like, let's say if you have the 5 million of customers, so the 5 million of customers will be like basically you can't send those many packets to 5 million of customers. So basically you start injecting the data into the DNS servers. Now from the DNS servers people are start consuming it. Now you think of like, okay, so another question which might you think of, like, okay, whenever there is an internet connection slow, what will happen and how this will happen? So basically those comes to your video players. Okay, now your video players nowadays are like far more smart enough, so they know like what kind of bandwidth you are having and what kind of pixel rate you can support. So in this particular case, so your player itself knows like, okay, what kind of pixels I want to consume. When your bandwidth or the bandwidth get improved, in that particular case it will start showing you the higher resolution, otherwise it will get start consuming the lower resolution. Now the thing is, like, when you are receiving the packets, how these packets like basically sends from this particular point of time from P1, these particular servers to this. So there is another protocol which helps you out, okay, and that is called HTTP live streaming. So it's HPS, if I am not wrong, the full form of HPS. So this is nothing that HLS, not HPH, HLS, my bad. So HTTP, there is a protocol. What it will do, it basically, in this particular case, what will happen? So whenever you are sending the information, what the responsibility of the HLS, it basically, it being developed by Apple, if I am not wrong, okay, long back, okay. So what it does is, it basically, let's say it has a one information or a kind of JSON, okay. This JSON has like what are the chunks or what are the segments, okay. Now whenever you receive the packet, so you can think of like, this is a big file, okay, this is a big chunk which we have received. We divided into the smaller parts, small parts, okay, and these should be in order, correct? These should be in order. This goes one after another, okay. So the responsibility here becomes like, once you receive the packet over here, okay, over the network here in this particular DNS servers, okay, DNS servers, what happens is like basically the person who is consuming the packet, your video player, okay, video player or the media player knows like which chunk I have consumed. So let's say it makes a connection to the DNS server, it consumes the packet number. So think of the packets are like this one, P1, P2, or chunks, whatever you want to say, P1, P2, P3, P4, P5, P6. So let's say you receive the packet of P1, you receive the packet P2, you receive the packet P3. So what it will say, like your media player will say like, okay, could you please give me the packet number P4, P5, P6, P7, or something like that. So this way. So you start receiving the packets in order, okay. So let's say whenever there is a stop or something, let's say you pause the video, okay, or live stream, you pause it. After that, when you come back, you see that your live stream will starting from the where you have paused at given point of time. So this way, like packets are always remain in order. So you, whenever you click on like forward it, like you press a button of like okay go live, or you say like okay forward it, in that particular case what will happen, like there are the few packets which they get skipped into, like basically they do not deliver, and they will find it out like which point you are asking for the packet. So at that particular point there is a request will be sent, and it will check like where your packet lies into which particular range, and that particular packet will be delivered to you over your network. So this is the like the complete bit of like how your system looks like in the terms of like when you're live streaming to the end to end people are talking about. Okay, so yeah, I think so I covered the most of the aspects. Another aspect, if you want to think of like okay in the perspective of it's in quite a deep dive. Apart from that, I did not cover a lot of things like where I can talk about the caching and all. I did not cover all those things. I did not went very deep dive into the how the real time messaging protocol works. Okay, all these things I did not talked about in a very deep dive. Okay, but I can send it out the notes for all the deep dives, like how the RTMP works, how your like basically HLS HTTP live streaming protocol works, then how your TCP UDP works, SRT secure reliable. I told you that is also I will send, and a complete system design of this particularly at the end of the session you will find the note very soon. There I will cover. So let's say if you are if you guys are quite interested towards like how your crick info or how they are collecting the information, so crick all these things in this particular in this system design, everything will be like end to end automated. There should be one camera which captures the unit, and after that everything gets delivered. So basically the processing happens, captures camera captures the events, encoders captures the event, it sends you out, and after that it will be received to at particularly at audience end. But if you are thinking of the crick info and all, there should be some manual data feeding. So there will be a person who is feeding the scorecard, correct? In your olden days you have seen whenever there is a cricket match happens, you will see that there is a big board, okay, where there is a scorer who keeps on updating the numbers, like okay like Congley made these many runs, Ponting hit these many runs, Afridi took these Afridi hits these many sixes, all these things, correct? So Shoaib thrown a ball in the at that much particular speed. All these are the manual like information which is like ingested into the system. Okay, that is called your scorer. Okay, so in the case of the crick info nowadays also, like if you think in the next to commentator there is a score there is a person who is keeps these scores handy. So it keeps on updating the score, and from that particular score or from the venue the other information like basically your servers like crick info servers, okay, start consuming the data, and they start building the analytics out of it. Second thing is like in the crick info you have seen that there will be like a continuous commentary that on the ball number 6.1 something happened, ball number 2 6.2 happened, something like all these are like commentators are doing something, correct? Like they are keeps on telling like okay there is a ball thrown, and after that this ball thrown at the speed of 160 kilometer per hour, and after that there is a another thing like it got a 6. These things are can't be captured so you need to think of like okay AI is smart enough or people are smart enough to get the data from what we speak. Okay, but it is very hard to get the information. Let's say if somebody is hitting a sixer, okay, so let's say somebody hits the 6 at this, how I can know that it's an 6? Okay, until unless someone tells like it's an 6, umpire tells like okay it's an 6, then only I feed that information. Okay, it is not calculating where ball is going, whether the two people are running 2 runs or not. So you need to think very cautiously. This is a manual effort. Somebody is feeding this particular data, and that particular data once it will be feed, in any of the format, like probably this is a ball number 6-1, the person who throws, the person who are coming, all these information, once the feed has been happened, then basically you start building up the analytics on the top of it. Okay, so this way crick info is like basically getting the raw JSON. You can think of like one JSON contains one ball information on, or one event of events happens in one event. In 1 minute could be any events happen, correct? Like in 1 minute two balls have been thrown. There are the certain runs. There is like there is an increase in the score of an individual player. There is an increase in the total individual score. There could be a wicket down. There could be a no ball. There is a lot of information. That information of 1 minute JSON is received by the crick info. After that, it parses out, parse that particular information. Once the parsing has been done, it basically displays you in the nums of ways of format, in the format like which you wanted to look into it, like where the individual score of a person, like how many balls has been thrown, all these information you start getting into it. Okay, this is how your crick info website works. Okay, crick info is nothing, it's like mostly collecting the data, do some analysis, and once the analysis has been completed, then after that you basically get the results. Now before any event in the crick info, or either in this particular case the live streaming, will be a certain setup happens. Now the certain setup, if you needs to think about what kind of setup will happen, so there will be a pre-preparation where some kind of ID will be given to a match. So okay, so there will be a ID which is fixed in number. So basically whenever the live streaming will start happening, so it has a fixed in number. So basically that event ID is always associated with this particular match. You will always provide it. You knows like the match is happening between which particular two teams. Okay, all these information, which person is coming into the ground, commentator keeps on telling, so and the scorer keeps on noticing. So think of in this particular manner, correct? Sometimes if you think like this is not an automated because people are feeding, let's say at the start of the match someone decided that that order of the coming of the players is this. Okay, in the middle of the match the captain changed the strategy. When the captain changed the strategy, it's like your next player who is going to come, that is only known to that particular team and only known to that particular players. It is not fixed. So that's why like we can't assure you that it's a manual feeding of the data. Okay, so next to commentator there is always an scorer which keeps on feeding the data, and on the basis of that particular feeding of the data you start building up the dashboards. Okay, once you have the data you can have a very simple system design. So basically crick info, if you think like okay scorer, so if I want to go into this crick info way of like how you will build the analytics system, so very quick overview if I want to give. So let's say you are sitting here. Okay, you are particularly sitting here. Now there will be like this is a scorer who is like updating the scorer. If I say this is a person who is updating the score, there is a crick info servers which are like getting the data, like actually pull based. Whenever this particular scorer updates the data, the crick info gets the data. It processes the data, like basically has the two views, one view here. It processes the data, how you will process the data. Another thing is like basically the scorer who updates the score is basically hits some API of the crick info, or like basically a API provided by you can think of like the BCCI itself or whosoever like providing the API. They update that info. Once the update of the info has been happened, it basically consumes the data. Once the consumption of the data happens, like basically it get updated here. Now once the updated here, it like basically it runs certain ways. So basically there will be an entry corresponding to that particular match, number of overs, number of ball throws, all those things we stores into the database. And what kind of database, if you are asking, we can have a fixed schema, we don't have a fixed schema. Okay, think of number of balls. A number of balls in a over could be anything. It could be go to 6 balls also. If it go to more balls also, you can have per over you can have a NoSQL database. Okay, but for a player, it a fixed number of players, they did not played and play not played, all those things you have the fixed schema. So all you can use a mix of both SQL and the NoSQL database to serve your data. So ultimately you are the audience here. You just do the query, give me the live result. The match has a particular ID, it goes to the particular ID, fetch all the information, and it just displays into the into your basically basically to your dashboards. Is that easy? Okay, so quick info, making the quick info is like becomes typical when you are thinking about how your schema looks like, how your one match event looks like. All those things you need to think of like at the low level design point of, then only quick info becomes a more uh, more challenging scenario, correct? So but scaling, it will be very easy. You have the load balancer. Now if you think about the or system design, the system design what we have developed for the live streaming, you can think of, okay, you can add as many as DNS server on the basis of like how many players you are getting. So that calculation you can do. Okay, so how many people or the audience you are expecting. Let's say you have the 5 millions audience, but you are expecting 5 million. So so whenever you do the such a back of envelope calculation, so try to do something more. So you, when you saying like 5 million I am expecting, I will say like, okay, uh okay, something happened. What happens? Just a second, guys. Yeah, I was there. So think of like, okay, if there are the 5 million people, if you wanted to do the back of the envelope calculation, you have basically 5 million uh, 5 million person who is going to watch the match. So try to do the back of envelope calculation by increasing some factors. So 5 million you can increase to some 2x. So your system should support 10 million. So let's say 10 million. 10 million I am ready to support. Okay, just in case. Okay, now 20 to 30% rather than 20 to 30%, think of like you directly increase it. Okay, sometime match will be get interrupted uh, because of the rains and all. In that particular case, you need to think of like, okay, my storage is also going to increase this for this particular match. That kind of scenarios you need to be get ready with. Okay, then you need to be take care of like, okay, sometimes okay, so there is a extension of the match. In that particular case, your storage will be increased. Second thing is like when you have the 10 million for people who are start watching the start watching the streams, then there will be a huge increase of the traffic. In these particular cases, you need to make sure that your system should be auto scalable. Now how to make a system auto scalable? All these calculations, all these numbers you should need to calculate before any event is going to happen. So let's say if there is an India and Pakistan match, it is one of the quite famous matches, like whenever it happens in the any of the platforms, and quite interesting also, correct? In that particular case, or let's say it's a World Cup final. Okay, in those particular case, you need to take care of like, okay, viewership, the total number of users you have seen like 5 million. Let's say there in the worst case 10 million people come, so your platform should be able to support 10 million also. Okay, so those auto scaling things you need to think of, like how you will auto scale your servers. All those can be done like easily if you are using any of the cloud environment. They like, let's say if you are using the Amazon cloud, in that particular case what will happen, you can actually set the time and window and what is the maximum number of servers you want with the present time of calculation. So at the given point of time, let's say at the time when the match happens, those number of servers will be scaled up as you mentioned it. All these things are getting into the part of the auto rebalancing and all. So increasing the number of servers, deploying those services, starting the traffic, and once the traffic has been over, then there will be the decrease in the number of servers, because the number of users will be uh, like basically get decreased. So all those things you need to think of. Okay, so yeah, I think so I covered most of the things in the perspective of like how you can scale the system, how you can build a real-time live streaming system. uh, this is mostly related to system design, but at the end of, you can expect like once I will be done with the live course, I definitely share the share the one doc which will be open link, where it has a proper system design with a complete architecture which I discussed, and with the explanation also. And do please let me know if anything is needed. But yeah, any questions, I am happy to answer those questions. Okay, so let me take one question. Computer science. Okay, so BGMI tournament. So I do not like basically do the preparation for the gate examination. I am not being involved. But Geeks for Geeks, I think so, they have the courses. But if you have any doubt related to computer science and something, you can reach me out over the LinkedIn. My name is Abhishek Tripathi, and I'm like presently working. I worked with Amazon, Microsoft, and few of the other companies. I uh, total yeah, that's it what I can say mostly. Yeah. Please let me know if you have any other question, guys. Any other question? I think so. There is a lag, and that is what the lag I am talking about. There should be some latency difference. Okay, so when you are when when you have a live streaming, probably you are getting my voice from my present voice, like after a latency of 4 or 5 seconds. Okay, so that is how your complete system, what we talked about today, is work. Okay. Yeah. I'll post my LinkedIn URL also at the chat window after the once this will be completed. And do let me know if you have any other questions related to this particular system design. I'm more than happy to answer it. If not, we'll end the session. Okay, 1 minute I'll take. I'll end the session otherwise. Okay. Okay, guys. Thanks a lot for joining. And as promised, I'll share the slides and everything. Rather than saying slides, to Google Doc link and my LinkedIn profile, so that you guys can connect, and you can have a questions, whatever the questions you have, I can answer them. Yeah. Thank you for joining. Thanks a lot, everyone. I'm ending the stream. Thank you. Bye, guys.